a new student, you just take advantage of our graders to do the testing for you. Towards the end of that semester, towards the end of 115, and especially the beginning of 116, we took that up a notch, and the TAs and instructors would always tell you, did you test your code? When you say it works on my laptop, but it doesn't work in AutoLab, we say, how do you know it works on your laptop, etc. So when we test something like this, we had this compute size example last week. If we wanted to test something like this, we would write a main method and print values to the screen. We would call our method with a variety of inputs, print the outputs to the screen, and then manually verify if these outputs were right. So this is what we always told you to do in 115, depending on who you had, hopefully everybody was telling you to do this, is, I gotta stand by my laptop, is call your methods, print the values to the screen, and look at them with your eyeballs and see if those outputs look right. And this is what we call testing in 115. There's a few problems with this. So this is great if you're not doing any testing, if you're used to relying on AutoLab. This is great. This is the next step, and it will tremendously cut down your debugging time to be able to see these values and actually be able to test on your own just by hitting that play button and in a few seconds getting some feedback instead of submitting to AutoLab, exporting as a zip, submit to AutoLab. That process can take a minute or two. This significantly cuts down your process and also gives you more feedback because you can print out any feedback that you want here. But this course being about larger projects, that's not quite going to suffice once we start writing larger programs. So what if we have a program with hundreds of files, all kinds of objects and classes defined all over the place, lots of interdependencies between these files, thousands of methods, and just a lot going on in a massive code base? How are we going to test that? And especially once we have a method or a function that is called by a lot of other code and a lot of different files across our program, and maybe those methods and functions are called by other methods and functions, we can have a lot of interdependency across this huge code base. So what happens then when we make one update in one function? Are we going to go visit every single one of those files that uses that function either directly or indirectly, run them all, print out a bunch of stuff to the screen, and manually verify every single output? Are we going to do that? I hope the answer is no. Even if you're willing to do all that work and to go through that tedious process every time you make a change, there's a lot of potential for human error in there. When you're quickly scanning through the output, you might miss something very subtle. You might miss something in there. Our goal here, and our goal really in general in programming, is to automate this process. We want to automate everything as computer scientists and as programmers. We're going to automate our testing. We want to be able to write code that's going to automate this process for us, call our methods, verify the outputs, and do that automatically. So if we write unit tests and automate all this testing, we make that one change in one file somewhere, well, we just run all our tests again and make sure they all pass them. If all our tests pass, and our tests are well written, we're confident that our entire project is still good to go. So that's our goal. That's what we want to accomplish. So with this, what we want with unit testing is we're going to write a series of tests where if every single test passes, we know our code is, well, we don't know our code is good, but we're confident that our code is good. This is our goal. And if even one of those tests fail, so we're going to call, say if we want to test just one method, like we'll do for today's lecture question, we'll call it with a bunch of different inputs and expect a bunch of different outputs. And if even one of those fails, our method is wrong. That's the behavior we want from our test suite. If even one of our test inputs pass, we're not going to say, well, it passed on 90% of them, so that's a 90, that's like an A. We don't do that in unit testing. The graders will give some partial credit like that, but out there in the world, I mean, you either have a bug or you don't. Your users aren't going to say, well, it was just one bug. It's either broken and works or it doesn't. So we're going to test a lot of inputs, and we should detect if even one of those tests fails and fail that code base. So code can be right 90% of the time. If it fails one test case, we're still saying that code does not pass this test suite. So let's see our first test suite. And we're going to test that method that we saw last week and that was on the few slides ago. We have this method that's going to tell us, take in a double and tell us if that double is small, medium, or large based on a few arbitrary cutoffs. We're going to test those doubles. And I want to write unit tests that are going to let me know if this method is correct. So what I'm going to do is come up with a couple of inputs. I'll get one from each category, call my compute size method, and make sure the output equals what I expect it to equal. We'll talk about Maven towards the end of the lecture. So let's break this down. First, I'm using a library called Scala test to do this. This is not built into Scala. It is a library that we have to download ourselves. We'll use Maven for that, and we'll talk about that towards the end of lecture. Once we get through the theory and what we're trying to accomplish here, we'll talk about that. And I'll go into IntelliJ and give a demo on how to set up Maven and everything. So we need to import our Scala test. This underscore, this is like a star in most languages. It's the wildcard. It means import everything from this package. Give me every object and class in this package. Just give it all to me. I don't want to say import this, import that, import every single thing. I am importing Fun Suite. Oh, I think that's the only import I'm using. And test, I believe, is part of Fun Suite, so that didn't matter. But I'm importing everything from that library, so if I do use more things from that library, I don't have to import each one individually. Next, I'm going to create a Fun Suite, which is short for Function Suite. I'm going to extend that, which is using inheritance. This is a topic for another week. We will talk about this, but it's not something we need to understand quite yet. But in plain English, we are extending the functionality of the Fun Suite class, which we don't know extends, we don't know class yet. So there's a lot in there to unpack. It'll take us a few weeks to get there fully. But for now, just know that you need this line when you write a test suite. And while I'm talking about that, for the homework handout code, and especially for this week's lab code, there are a lot of topics used in that code that I give you that you shouldn't understand yet. So if you're looking through that code and you don't know what all the syntax is and what's going on, that's fine, that's expected. By Friday, you should be able to understand every piece of the homework handout code. You'll be able to understand all that. But it'll take a while to get through, the next 4 weeks it'll take to get through all of the lab code today. And you should be able to start everything with the homework, with what you have now. The only thing is accessing variables in objects using the dot operator. If there's, say the game object class has a location variable inside of it, you would use the dot operator. So you'd use your game object variable dot location, and then to access x, y, and z, you would do dot x, dot y, dot z, and treat those as 3 separate variables to be able to get all those values. So with that, you can do everything with the homework. You can do the whole thing. But that'll make more sense. We'll go into it more in depth on Friday, that specific syntax. So don't get scared if there's stuff you don't understand. We will go through things. Not every piece of syntax, but we'll go through all the concepts of what's going on here. And finally, defining a test. We're going to use this test syntax, test. We're going to give it a string as an argument, and then we're going to give it braces, to give it a body using braces. And inside here, this string first is what you're going to name your test. This is just a string to help you with the feedback. When you run your test is going to say the test name and whether it passed or failed. So that's just to help you get an idea of what test is being ran, so you know what to expect when you're looking at that output. Then in the body of the test, this is where we're going to do our actual testing. We're going to set everything up. We're going to call our methods. We're going to test everything that we want to test. We're going to do that using these assert functions. So we're going to call the assert function or method. I believe it's a method. I mean, it's a subtle difference. But we're going to call assert with either 1 or 2 parameters. The first one in either case is going to be a Boolean, which is whether the test passed or failed. So I'm expecting when I call this conditional on 70, I expect this to equal large, so I'm going to write the Boolean expression, this output of this method call equals large, and that should be true. So that needs to be true. If this is true, then this assert passed, that test case passed, and if that's false, this test case failed. And once one test case fails, the whole test suite fails, and it says this code's no good. So this will pass, hopefully, this should pass. This should be true, this should be true. And if any one of these are false, and if there's a second parameter, a second argument, it's going to print the second argument as a string to the screen. So if one of these fails, I just want to see what input did I give it that I failed. And I could give a more meaningful message. I didn't want to fill up the slide too much, but I could give a more meaningful message like tested compute size on input large double. Output was expected to be large, but output was actually conditional.compute size of large double. So I could put all that in there to give myself some more feedback on what happened with that failure. Here I'm just printing large double. That's going to give me enough information to figure out which one of these three failed in this case. And if we ever expect one of these to be false, we use all of our Boolean operators. I could put this whole thing in parentheses and just put a not here. Or I can use an assert false method, which is in the Scala test library, or I could do not equals here. Just different ways that I could do, that I could handle that. So I'm testing this on these three inputs. They should output large, medium, and small respectively. But my next question is this enough testing? Is this a good test suite? No, it is not. So this is okay. It passes my correct solution. If the solution is correct, this test suite is going to pass the correct solution. But the problem is, what if I have this? Assuming our cutoffs. Oh, that was the correct solution. So here's the correct solution. We're assuming the cutoffs are supposed to be 60 and 30. This passes, our test suite passes this solution. But what if our solution is this? This is a wrong solution, has the wrong cutoffs. Yet the way we set up our tests, this passes. Our tests are going to run on, I forget the exact numbers, but these cutoffs are off. Our test suite still passes it. And we're not feeling good about that. This wrong solution, wrong code passes. Now we're going to release our code. Somebody's going to test these boundaries a bit, just have situations where they're using our app that is close to those boundaries. They're going to get the wrong values. They're going to be mad. We're going to have bugs in our code. Customers are going to be mad. Things are bad at that point. So we want to do a little bit better testing here. Let's check really close to these boundaries. Let's test each boundary to make sure that we're doing the right thing on each one. So are we doing the right things for each boundary case? So here we want to check right at the boundary, which was, we are saying if it's right on the boundary, that's going to go to the next higher thing. So greater than or equal to 60, greater than or equal to 30. So let's check right on the boundaries. 60 exactly should be large. 59.99, that should be medium. We could even add more nines there if we'd like. Right on the lower boundary, that should still be medium, but just below it, that's going to be small. So we can test, get a little bit tighter testing, a little bit more thorough testing. We want thorough testing to make sure that we don't accidentally call our broken code good and then release broken code out there. So is this enough testing? So I'd say we can reasonably stop here. We can do more testing if we want, but we could reasonably stop here and we get pretty much anything. We haven't thrown negatives at it, so maybe we could do something like that. But we're going to get pretty much anything except some really crazy wrong solutions with this one. However, maybe we should go that next step further and do some more testing. So this is a tough question of where do I stop? What's enough testing? And especially once you move on, when you graduate and there's no auto lab, or you have an internship, there's no auto lab, no grades or anything. you're going to have to answer this question for yourself. When am I satisfied with the level of testing that I'm doing? At what point am I confident that if my code passes these tests, that it is in fact completely correct? At what point? So that's a tough question. We always have to ask ourselves as developers. So if we want to go further with this, we can start pulling in our data structures, fill up data structures with test cases, and run those test cases in loops to be able to test a lot of cases kind of rapid fire. So if I have a lot of values that should be large, a lot of values that should be medium, and a lot of values that should be small, including some large negative values, just to make sure that I'm not maybe taking the absolute value and counting those as large or something like that. I want to make sure that I'm not doing something silly like that. And just a quick example, since we just saw data structures last lecture, if I want to add a value to a list, just an example of that. Later on, I decide, hey, I have another double that I want to test, a very, very large double. I'm going to use this syntax to add it to the list. And very importantly, I saw this mistake a lot from students, is reassign the list variable with that new value. So I'm adding this to that list. That's returning a brand new list, and I'm reassigning that to the list variable that I already have. Lists in Scala are what's called immutable. A list cannot change. So each time we want to change a list, we're actually creating a brand new list, returning that list, and then we have to reassign that variable to that new list. Similar to strings, strings are immutable. When we concatenate two strings, we have to reassign that to the same variable if we want that change to reflect. We don't have anything like list.append that we would have in Python. We don't have that functionality in Scala. So we're going to add that to the list and then reassign that list to make sure that we have the newly created list stored in that variable. Then iterate over those data structures and call our asserts. This is where this feedback comes in very handy. If this fails, I don't want to guess which one of these inputs failed. So I'm going to print out large double, and I would definitely want to add more here if I were testing this method. Large double expected large actually gave me whatever it actually outputted. I would want to have a little more logic there, but I want to fit this all on a slide. It's my excuse for that. So I want to know which input it was, and then I can go from there to see what happened in my code on that input to see what I can fix. And for other methods, including the lecture question, if you want to set it up with a data structure, which I recommend for the practice with data structures, you would want to set that up as a map. If you have a map of doubles to doubles, which maps inputs to outputs, store a lot of test cases in that map, and then iterate over the map, you can have a lot of tests without having very cluttered code, doing all those tests individually. All right, any questions on what we're doing here, how to set up the unit tests and everything? The rest of my slides are doing this in IntelliJ, giving a live demo, and kind of fixing a broken repo. Any questions on this so far? Cool. All right. So let's talk about some logistics, grading, IntelliJ, and whatnot. So in this class, and especially in your homeworks, but to include today's lecture questions, some other lecture questions, next week's lab, and maybe some other labs, and possibly your project. It won't be exactly like this, but in your project, that won't be the same structure. Anyway, we're going to follow this grading structure. I don't know what to call it, but when you submit an objective that contains unit tests, so the first three objectives in the homework, excluding the primary and the bonus, you're going to have to submit your code and your test suite that tests that method, that code that you wrote. Now on the grader, I'm not going to test your code. I don't have tests written sitting on the grader that are going to check if your code is correct. That's up to you. In this class, that's up to you on those testing objectives to be able to test your own code. What I am going to do is run your test suite against your own code, which certainly should pass. You should be testing that on your own and making sure that you're passing your own tests. I'm going to run your test suite on a correct solution that I wrote and put on the server. Your test suite should certainly pass that as well. And then I'm going to run your solution on a number of incorrect methods. So I'm going to have methods that are wrote improperly, and your test suite should fail all of those incorrect solutions. So the assumption is if your test suite passes both of those, both the correct solution and your solution, those both might be right, but you also might just not have thorough testing. So if your test case was just assert true, you're always going to pass, and both of those are going to pass. Where you're really earning your points is where you're passing a more thorough test suite. So once you start failing the incorrect solutions with your test suite, then we can start being more confident that your code handles things that those incorrect solutions don't. So if you're handling those things that the incorrect solutions don't, and if I have enough incorrect solutions on there, then your code's going to be right, and I can infer that your code's at least mostly right at that point. Enough that AutoGrader is going to give you the points. So for grading, if you don't pass both of the correct and your solution, that's just a flat out 0. You got to at least pass those ones. Your test suite has to pass those ones. So like I said, just assert true would do that. And then after that, for each incorrect solution that your test suite fails, you're going to earn a fraction of points. Those points will be linear. For example, the objective 1 on the homework is 30 points, and there's 6 incorrect solutions. So each one of those incorrect solutions is worth 5 points. So it'll be a linear scale. So you can earn some partial credit on those, which everybody from last semester is jealous because they had 0 partial credit. They had to get all of them correct before they got any points. So that I believe will be a welcome change this semester. Okay, so that's kind of the logistics of grading. That's just a course-specific thing. Let's get back to some stuff that will live outside this course. Maven. So we needed this external library to be able to run these test code, to do this unit testing. This library doesn't exist in Scala. It is a library that we have to download, add to our project with a link to our project and everything, which can be a tedious process. So we're going to use a tool called Maven to be able to take care of that, to be able to do that for us. Maven is going to work through a pom.xml file. If we save a pom.xml file with an exact specific format, save it in the root directory of our project, and then run Maven, it'll look at that file and download any dependencies that are listed in that file. And Maven is a very powerful tool. There's a lot more that Maven can do for us. For this semester, we're just going to use it for dependency management. We're going to list our external libraries in that POM file, and then we're going to use Maven to download those dependencies. This is very similar to the requirements.txt that we used in Python in 1.15, where we listed all of our libraries in there, our bottle and, I forgot what the other ones were. The one for encryption, and I think a few other ones. But we listed our libraries there, and then Python would install them for us, would install those files. Doing the same thing here with pip. We would use pip instead of Maven. We would use requirements.txt instead of pom.xml, but the same concept here. We have dependencies, we need to install them. We're going to use some tools and some formatting to be able to do that for us. So let's do exactly that. So I have here the code from the slides, and I have one test suite. By the way, we can have separate tests inside a test suite. I have all 3 of those tests that we saw in the slides all in one test suite. So these are all tests. Each test has certain test cases, and all of these combined is one test suite. So just some terminology there, some vocab. But this is broken right now. And if you just clone the CSU 116 examples repo, your code's going to look something like this. Everything's going to be broken. You're going to see a bunch of red everywhere. It's going to say, I don't know what any of this is. It's going to say can't find Scala test when we run this. If it runs. So it's not going to compile because we don't have Scala test installed. And apparently it doesn't even want to try. Well, okay, so let's look at this pom.xml file. So we have this file. It is in the root directory of our project. So it's right in this top level directory. If it's anywhere else, Maven's not going to see it. So we have to have it in this exact folder. Cloning this repo, it's going to be there, just that's where it is. If you're setting up your own project, just make sure your pom.xml is in that location. It's in that root directory of the project. So I have my pom in that root directory, and all of this part in the project, you can treat that as boilerplate. You can just cut and paste that from the example POM that I have on the course website. If you want to change your group ID, if you have some ID that you want to use and some artifact ID, that's just the name of the project and what group it belongs to. If you want to change those, I mean, you can go for it. The version number, this has to be exactly this. We're using POM 4.0.0, which is the current version of POM. We need that and this URL to be exactly that, so Maven knows what to do with this POM file. And the version, this is the version number of our software. We're really not using versioning this semester, so this can be whatever you want as well. You can leave it at that. So if you don't want to edit any of this, just cut and paste that verbatim. And then the dependencies, and you should have seen some HTML, of course, in 1.15. You've seen some HTML. This is similar syntax, but it is XML, not HTML, but similar idea, open and closing tags with properties. So we're going to open these dependencies and then list, this is the part that we really want, we're going to list every dependency for our project. So this is listing every external library that needs to be downloaded before we run our code. And one of these is Scala test. So we're going to download Scala test using Maven. And Maven in the corner here is even telling me like, hey, you have something in your dependencies that I haven't downloaded yet. Should I download that for you? If you see that box, just click import changes and you'll be good. If you don't see that box, there's this Maven button on the sidebar. Click this and then click the refresh button right here and it'll download all your dependencies. But some of you won't have that Maven in the sidebar. That's the one I really want to talk about. So that gets a little trickier. So if you don't see Maven in this sidebar, which quite a few students in lab had, we had this issue. It should be there by default. Mine was, most of it, anyway. If it's not in there, there's this magnifying glass, the search option right above that sidebar. Click on this. Search for Maven. Ugh, if I can type. Search for Maven and find that refresh option. Re-import all Maven projects. And I want to do one thing before I do that. Let's go back to our broken code. Maven, re-import all Maven projects. If Maven isn't in your sidebar, after you search for it and use it, IntelliJ will say, hey, it looks like you want to use Maven. Let me add that to your sidebar for you. So once you do this once, you should always see Maven in the sidebar now. And once I run that, it downloaded my dependencies. All my red text went away. Everything works. And I can almost run this. Well, we ran into a lot of other issues in lab yesterday and this morning, and I want to talk about this. I purposely broke my IntelliJ setup to show you how to resolve these issues. So if you are seeing these same ones, we can resolve these things, we can get past these. So what I have, oh, I can't even zoom in on that. Well, what I have here is a cyclic dependency error. What causes this is in my POM, for each library I'm installing, I'm specifying the version of Scala that I'm using for that library. And I have 2.12 for each one of these. But if I go into my project, I'm running Scala 2.13. And if you've just installed IntelliJ for this class, which most of you have done, pretty much by default, the default option is to download Scala 2.13. And I'd love to just use 2.13 and update the POM to use 2.13 version of every library, because if the library and the Scala version are out of sync, it unfortunately does not work, which frustrates the crap out of me, but it's the reality we live in. So if those are out of sync, it doesn't work. I'd like to update all the POM files. Unfortunately, all of the libraries that we use in this class haven't been ported to have 2.13 support yet. So we're going to do the unfortunate thing and roll back to 2.12, the latest version of 2.12, and use that so we can use all the libraries that we need for this class. I saw the Scala FX library specifically. I saw a message from the creator. He's working on 2.13 support. Hasn't gotten there yet. 2.13 just came out in June, so all the libraries haven't quite gotten there yet. They haven't updated to the new Scala options yet. So it is what it is. So when we want to update, I'm going to select, I went to File, Project Structure. I went to Global Libraries on the side. I'm going to select my Scala SDK 2.13. If this already says 2.12, you're good. You don't have to update anything. 2.13, and I'm just going to click this minus button and remove that. Then I'm going to click the plus button, Scala SDK. I'm going to click download and select my version there. This isn't a select option. I thought it was at first, but I'm going to select 2.12.9. Click OK, and that's going to download Scala 2.12.9, the latest version of Scala, which came out less than 30 days ago. It is actually more up to date than Scala 2.13.0, which is the latest version of 2.13, so go figure. But it doesn't have the updated API. They changed the API in 2.13. I'm going to click OK to apply it to my project. And now I have Scala 2.12.9. Click OK. Go back to my test suite, run that thing. Wait for it to compile. And I got a green bar. Green bar is what we want to see. So it ran all of my tests. Everything worked properly. I got a bunch of green check marks. That means all of my tests passed, so my code is good. My compute size method is looking good. So, and everything ran. There's one more thing. If I try to run, I don't have it in this repo, but it'll be for the lab code. Unfortunately, this is frustrating. I know it's frustrating for you. It's frustrating for me. The version of Java as well. If we use Java 12, it's not going to work with Java FX. It's these graphics libraries that are giving us the pain. We weren't for these graphics libraries, but we want GUIs. We want to be able to see our code and play our games and stuff. So not giving up on the graphics. But if we're running Java 12, unfortunately they removed Java FX. It used to be built into Java. They removed it from Java, and getting it back into Java, I was hoping would be as easy as adding it to the POM file. I have not found that to be the case. I'll still be searching for some solution to this, some better solution. But what we're going to do, at the very least in the meantime, is roll back from Java 12, if you're using 12, if you download the latest JDK, we're going to roll that back to Java 8, which the link I gave in the homework, it did say Java, well, maybe I'll have to check that. JDK 8 works well with Scala in general. But we're going to roll that back. So download JDK 8. I already downloaded it because I'm not going to have you just watch a download progress bar. But I've already downloaded and installed Java 8. But you have to be aware of where that installs to. And it doesn't give you an option of where to install it. So if you go to your Java 12, click this folder icon here. Go up a few directories. So I have this JDK 12 right here. I'm going to go up one more directory to Java virtual machines. It may be different depending on your operating system and whatnot, but go up one directory above Java 12, and I'm going to select this JDK 1.8.0.131 or whatever version of Java 8 you installed. I'm going to select that entire directory, click Open, and click OK. And once I do that, I'm running Java 8. Now my Scala FX and my Java FX are going to work the way we expect in the class. So some version issues, it's unfortunate. We went through these headaches in lab yesterday. This is the simplest solution, in my opinion, that we can have. Unfortunately, it does mean rolling back versions, but we're not, as part of the course, we're not using the latest cutting edge features of these languages past Java 8 and Scala 2.12.9 anyway. We're not using those features, so there is some loss there, but really nothing too critical. Okay. If there are questions with that, I'll be walking around for the next 5 minutes or so. And wait, I got one more thing to say after that. And I have office hours after this if you want to come to my office after class. But one more thing I want to mention. So the lecture question, of course, if you go one slide after the lecture question, there are 5 incorrect submissions for this question, each worth 2 points. And just to make sure everybody understands what's going on with these testing objectives, I have the code for these 5 incorrect submissions. For the homework, you won't be given the code for the incorrect submissions, but you'll be given the code name, which is just some cryptic message that I give you to give you a tiny bit of information, to give you kind of a hint of where to look. So you can get an idea of what those mean in the code. So take a look at those on that last slide. I'll leave the lecture question up while I walk around. With that, I'll see you Friday.